In this activity, we'll be creating a program that processes user input. Once you're ready, fire up Visual Studio Code and we'll get started. Once Visual Studio Code loads, navigate to your Activities directory. We are on Activity 20, so double-click on A20. Once the activity file loads, review the topic and program requirements. Attempt to implement a solution on your own with the video paused. Once completed, resume the video and I will demonstrate my implementation as well as provide insights to the activity topic. Alright, let's dive on in. This activity is about user input. The requirements are to verify user input against predefined keywords. The keywords represent possible power options for a computer. So here we have 5 options listed out that we need to be checking for. If the user enters one of the keywords, a message should be printed to the console indicating which action should be taken. So if the user types in shut down, we should display a message such as shutting down. And if the keyword does not exist, we need an appropriate error message. In our notes, we see that we need to use an enum to store the possible power states. We need to use a function with a match expression to print out the power messages, and the function should accept the enum as an input. We need to also use a match expression to convert the user input into the power state enum. And lastly, the program should be case insensitive. So the user should be able to type reboot with capital letters or lowercase, and it should work just fine. The first thing I'm going to do is copy in these power states and create an enumeration. So we need to create an enumeration. I'm going to call mine power state. And then I'll just copy in each one of these. That way we have all of our states available for usage in our program. Next, I need to use a match expression to convert the user input into the power state enum. To do so, I'm going to use an implementation block. So that'll be the impl keyword. So we're going to implement functionality for the power state enumeration. I'm going to call my function new. And it's going to take a state as a string slice. I'm then returning an optional power state. Now, the reason I'm doing an option is because the user can type in anything they want. So if the state that they typed is not one of these, then we'll just return none here with our options. So that'll be none if they type in something that is invalid. And if they type something that is one of these power states, then it's going to be some with some power state as the data. Next, I need to change the state that's supplied by a user and make it all lowercase or all uppercase. I'm going to do that in order to perform a match expression on the state. If we don't do that, then we would need to match on all possible cases of lowercase and uppercase letters in each letter, and that would be a pretty large list of matches. So if we just make the state, I'm going to do lowercase. If we make the state lowercase, then we can do a match expression on it quite easily. And then we can just match on each possibility if they are put here in lowercase. So I'm going to make each one of these a lowercase possibility. And now I just change the case here real quick. So now we have each state as a lowercase possibility. Next, I need to return the proper state when this state is input by the user. When we return options, we have to use sum if we're going to return some data. So sum is going to wrap our data, and we just wrap in a power state, and that will be off. And then we do the same for the rest of them. In the event that the user types something that is not listed here, the underscore will take care of that scenario. And when that happens, we'll just return none. And that would indicate that we cannot make a power state out of the input that the user supplied. One additional thing that I want to do with the user input is do a trim call. So trim will remove any extra white space, including new lines. So any spaces, tabs, or new lines that are present in the user input is just going to be removed. And then we're going to change it to lowercase. That way, when we do our match, everything will already have all the spaces removed from both sides, and there won't be any new lines. That way it's easier to match on the input. Next, we need to use a function with a match expression to print out the power messages, and the function should accept the enum as an input. So I'll copy that note down into our program area, and we'll create a function for that. I'll call my function print power action. That will take in a power state, and that is a power state enumeration. And that won't return anything since all we need to do is print out a message. And now we can use a match expression on the state. I'm now going to copy the variants in so I can just get them really easily. So I'll go up here, I'll copy them, and then paste here. There's a trick that you can do in functions like this. We know that our function is only ever going to do one thing. All it's ever going to do is print out the power action. So all we're ever doing is matching on this state, and we're just going to print it out based on this. And this function shouldn't do anything else besides that. So what we can do here, instead of having to type in power state off and then, the same thing for each one, instead of doing that, we can use everything in the power state. As an example, we can type in use power state and then an asterisk. The use keyword, it uses modules from the standard library, and you can also utilize it for using different items that are available in other parts of your code. So I'll split this so we can see what's happening here. So when we use the power state, we're using this power state here, and then the 2 colons always represent a path traversal. So we're traversing into this power state right there. So we're going from this power state into each variant here. And what this means with the asterisk is just take everything from here and just stick it within these curly braces right here. All of these variants here will be available within our function here. So we can just type in these directly, and we don't need to actually have this power state listed each time. You'll want to use this sparingly because it's really easy to get words mixed up with keywords and variables with large functions. But in this situation, we have a single function. It's doing only one thing, and there's nothing really else that's happening besides a single match block. So this would be an appropriate usage of this type of technique. So now I can just add our print lines. The next thing we need to do is get our user input. I'll be doing that in the main function. When we're getting user input, we need to first create a string buffer. This is what will hold the user input. I'm then going to hop into the Rust documentation so we can figure out exactly what module to use for our input output and how to use the functions in that module to get user input. So I know I'm looking for the IO module, so I'm just going to type in IO. Here we'll go to the IO module. I'm going to scroll down to the standard input and output. Here we can see we need to use the IO module in our code. So I'm going to do that now. To get input, we need to use this line here. So I'm just going to copy that into our program. So this line here will actually get the standard input and then read the line and place the input into the buffer supplied here. So we'll need to change this variable name to correspond to the variable name that we use, which is buffer. We can see that the example uses the question mark operator. I'm not going to be using that for this example. Instead, I'm going to assign this to a variable. I'm going to call this user input status. And I'm going to check the status. So if user input status dot is okay, then we're going to do what we need to do with the text. The is okay function is defined on results, and we know that the readline function returns a result. We can confirm this by looking at the documentation for the readline function. So if we just do a quick search, we can go to readline, and we can see here that it returns a result. And the readline function actually returns an integer, and it returns the amount of bytes that we read instead of the actual data, because the data is stored within this buffer. If we go back to our code, we can now create a power state using the data within this buffer. To do so, we need to call the new function that's implemented on the power state enumeration. I'm going to match on the new function here within power state. So we're just going to do a match, and then we'll match on power state new. We'll then pass in the buffer as a borrow, so we have a reference. Remember that this buffer right here is a owned string, and the power state new function requires a borrowed string. So we have a string slice here, which is borrowed, and we need to convert it from a string into a borrowed string. So we just use the ampersand to borrow the buffer. Now, as we can see, our new function here on the power state, it returns an option. So our possibilities in our match expression are going to be sum, and that will be the power state. So if we do get a power state, we can take some actions. And if we get none, then that means the user entered something that is not listed here as a state. So if it's none, I'm just going to print out invalid power state. Now that we have our power state right here, we'll be able to call the print power action function using that state. To do so, all we need to include is the function name along with the state. We can close this side now. After that, we just need to handle the else block for this particular if expression. And what happens here is the else block will be reached if there was some error reading the line from the standard input. So this will just indicate error reading input. I'm not going to print out the error message in this case. We're just going to print a generic message saying that some kind of error occurred. This program looks like it's just about complete. What we can do before running it is we can open a new terminal and type in cargo check. We are on activity 20, so you can do --bin A20. And what cargo check does is it will run through your code and find out if there's any errors, and it will just display the errors to the terminal. You can use this as an alternative to cargo run if you don't need to actually run your code and you just want it to be checked for any errors. It's good to check for errors frequently, just in case something was missed. The compiler is really great at showing you error messages and describing the exact problem along with where it is. And the best part about using cargo check instead of using run or build is cargo check runs faster than running the other commands, because check just checks the code. It doesn't actually generate anything that you can run. So if you specifically just want to make sure your code is okay, you should use cargo check. That way it runs fast, but you still get all the great benefits of the error messages. I'm going to run this and see if we have any errors. Looks like we have quite a few. We have 6 errors. So when you're working with errors from the compiler, you always want to start from the very first one, because sometimes the very first error causes additional ones to propagate downward. This would mean that it's possible to fix the first error and it would fix all the other ones. So I'm going to scroll to the top and see what the first error is. Here it looks like a syntax error. So this looks probably in my match expression. It looks like I forgot to complete the fat arrow. So I'll fix that now. That's on line 52, so we can jump straight to line 52. As we can see, that's the case. So I made my arrows just fine here, but then here I forgot to create the arrow all the way. So I'll fix that now. You can then run the cargo check again to see what happens. We still have 5 errors. Let's start at the top. Mismatched types. So we have a type error, and that's on line 46. And it tells us exactly what the problem is. It's saying that our state, when we're matching on the state, it has a type of an owned string, but these ones are string slices. If you recall from a previous video, when you create a string in this manner, it's automatically a slice, which is a borrowed string. So strings by themselves like this are always borrowed. But in this case, our match expression is matching on an owned string, and match has to operate on the same type. So what we can do is we can just borrow the state right here, which will then create a borrowed string, and the match should work properly. Let's do that now. So this is on line 46, so I'm just going to jump straight to line 46. Also, instead of having to manually go to the line, you can just control-click on the source line right here, and it'll jump straight to it. As you can see, it jumps straight to the code that's having an error right there. So I'll close this. What happens here with the state variable, the trim function works with a string slice because it can just slice into an existing string by removing the spaces. However, when we call to lowercase, it's modifying the string. So what happens is it creates an owned string because you're unable to modify a string slice. And additionally, this is not mutable. So there's no way we can actually get a string slice once we call this function. To get a string slice from this owned string, all we need to do is call the .as_str function. What that is doing is it's turning the state, which is a string, I'll add a type annotation. It's turning that into a string slice. So once we call the lowercase function, we end up with a owned string here. And then to get a string slice from an owned string, we just call this function on it. And all of these are automatically string slices. So we have to make sure that our expression here with the match keyword is also a string slice because they all need to be the same type. Now that we have that change, let's run cargo check again and see if we have any errors. As we can see, the cargo check tool, it checked and finished checking the program, and we have no errors. If there were any errors, they would be displayed here. So this means that our program is ready to go. Before running this program, I'm going to walk through it so we can see exactly how it works. We'll start from the main function. First, we're creating a mutable buffer. This is what will store the user input. We then call the standard input function on the IO module to get the terminal. And then we call the readline function on that terminal and pass in our buffer. This function will read the data from the terminal, save it into this buffer, and then we can access this buffer later to get the user input. This function returns a result. On the next line, we're checking to see if this result is okay. And if it's okay, we're then going to continue processing the user input, which is now safely saved into this buffer. We then have a match expression. We're matching on the power state enumeration, specifically the new function that is implemented here. We call the new function with a reference to the buffer, since the new function here takes a string slice, and this is an owned string. If we use the ampersand, it will convert it into a string slice for us. Over here in the new function, we are creating another variable. This is called shadowing a variable. So as we can see, our function argument is state. And if we create another variable called state, this one will supersede the one that's defined as a function parameter. So once we create this state here, this one is no longer accessible within this function body. This is useful in scenarios where you need to change the type of the data, as we are here. We're changing it from a string slice into an owned string. We then take the state, which at this point is a string slice. We trim off any excess white space or new lines, and we then convert the entire string to lowercase. This lowercase conversion causes it to be changed into an owned string because it modifies the characters. Next, we match on the state, which at this point is an owned string, and we convert it back into a string slice by calling the as_str function. We need to do that because when you type in strings like this in code, they're automatically created as string slices. And when you use match, all the types must be the same. So when we do that, all the types will be the same for this particular expression. We then match on all 5 of these words. And if any one of these are encountered, we return a power state that represents the appropriate state. So for off, we just turn it off. Sleep, we go to sleep, etc. If the user types in anything else, we're just going to return none. Once a value returns, it'll be returned as an option, which will have a power state or nothing. That will then be returned back here to this match expression. If we have a power state, as indicated by sum, I'll create a new variable called state, and we will then print out the power action based on that state, which at this point is now a power state. If we get none back, if the user types in something that is not listed, it's going to print out invalid power state and the program ends. If a state that is appropriate is provided, the print power action function is called, which accepts a power state. The first line here in the print power action function is taking the power state enumeration. It's grabbing all of the variants listed here, and it's making them available within this function block. So everything within the parentheses, you'll now be able to enter off, sleep, reboot, shutdown, and hibernate without referencing the power state itself. This just makes it easy to type out the match expressions because we don't need to include the power state word on each one of these variants. Since this function only does one thing and nothing else, it's okay to use this, but make sure you use the asterisk sparingly and only in situations where it's obvious what's happening. We then match on the power state provided to the function here. And if it's one of these states, then we print out an appropriate message. Since we're using an enumeration and a match expression together, we have to account for all possibilities, which we are doing here. And so it'll print out the appropriate message and compile properly. The last thing to cover is this else portion of our if-else expression. So when the readline function succeeds, we will get an OK value here. So this is what happens when it's OK. If we get an error, then we will execute this else block. So we're checking, is the user input status OK? If so, we do this. And if it's not OK, we're just going to print out this error. We're not going to detail the error message to the user. We're just going to say that there is some kind of error reading the input. So now if we run the program, we can see if it works. To run the program, go to Terminal, New Terminal, type in cargo run --bin A20, since we're on activity 20. I specifically left out the -q flag. That way we know once the program starts running because it's waiting for user input. I'm now going to type in one of these states here, and we'll see if it works. So I'm going to type in reboot. And now we have the message rebooting. As we can see here, we got the appropriate message. I'm going to try it with a word that's not listed here in our states. I'll call it turn off. Now we see we have an invalid power state. It looks like this program is working properly. One modification we can make to improve the usability of this program, as you can see when we run it, there's nothing here being displayed. It's just a cursor. So it would help if we displayed a message for the user so they know what to do next, because they might think the program is running or broken or something. Let's add that. All we need to do to make the program more usable is just add a print line. So we can print out enter new power state. And then if we run the program again, we'll see that we have this little prompt asking us to enter a new power state. So we know that some action needs to be taken. We'll do a hibernation. And now we get the appropriate message that the program is hibernating. This concludes the activity on user input. I'll see you in the next presentation.